Another slightly challenging day. Today we're going to talk about division, and more importantly we're going to talk about radicals in your denominator, which you cannot have. So what we're really talking about is how to get rid of the radicals in the denominator, because that's what a division problem is, a numerator over a denominator. You have two options. Only one of them can be used all the time. This option says that if you have a radical over a radical, you can write it as one fraction. And then once you have it written as one fraction, you can go ahead and simplify that fraction so that it's just a whole number. If that's just a whole number, then you get rid of the whole bottom part of the fraction, which means that you no longer have a radical on the bottom. It's okay to have one on top, we just can't have one on the bottom. So, for example, example number 1. When you're looking at this, you can see that 2 goes into 6 evenly. That's the trick. If it doesn't go into it evenly, so that you're going to end up with a whole number, you can't use this. So, since 2 does go into 6, then I can write this as all one fraction. And say 2 goes into 6 3 times, which gives me the square root of 3 for my answer. Everything's good. But that's not always going to be the case. Sometimes you're going to have to rationalize the denominator. In fact, you got to do it a whole bunch. It's going to happen a lot. Whenever you're told to rationalize the denominator, you have to end up multiplying the top and the bottom by the same thing. So in essence, you're really multiplying by 1, so you haven't changed anything. But since my 1 happens to be this, that means that something pretty cool happens to the bottom. So I pick something, and you can pick anything out of the clear blue sky that you want to pick. But I pick something specifically so that when I multiply this times that, I end up with something that's a perfect square underneath, so that I can take the square root of that. That's the whole goal, to get rid of that radical on the bottom. So, as an example, look at this one. Now I know what you're saying. 1/2 is not a radical. I mean, there is a radical there, but it's not over the 2. But it is. Just like we had this rule over here where you can take something that's split up and make it 1, this is the same thing as saying square root of 1 over the square root of 2. So that radical really is on the bottom. So we're going to have to multiply the top and the bottom by something that's going to make that bottom be a perfect square. And generally speaking, not always, but generally speaking, that's going to be whatever number is on the bottom. So I can multiply this by the square root of 2. That's going to give me the square root of 4 on the bottom. And you can take the square root of 4. But if I multiply the bottom by that, I also have to multiply the top by that, so I don't change anything. So now the square root of 1 times the square root of 2 is really the square root of 2 over the square root of 4. Now we can't take the square root of 2, but we can take the square root of 4. The square root of 4 is just 2. Now I don't have a radical on the bottom. It's still a fraction, but that's okay. I don't have that radical on the bottom, it's just on the top. How can you tell when it's over the entire fraction and not just on the top? If it's over the entire fraction, it should dip all the way down to in front of that bottom number. So because this one dipped all the way down, I knew that it was really that. Just like over here, I made it dip all the way down. Up here, I made it dip all the way down so you can see that whole fraction was underneath it. Let's look at some more. Example 3. 4 square roots of 3 over 2 square roots of 8. Now remember, my goal isn't to multiply it by whatever's on the bottom. My goal is to make sure that I can take the square root of whatever's on the bottom. That whatever's underneath that radical, I can take the square root of it. So I have to figure out what times 8 is going to give me a perfect square. Well, knowing the list of my perfect squares might be helpful. So there's 1, 4, 9, 16. Oh wait, 8 goes into 16 2 times. So I should be able to just multiply this by the square root of 2 on top and on bottom. Now if I multiply it on the bottom, because that's the one we have to check and make sure about, so that's the one I'm going to multiply first. It's about the only time I ever do that, where I take care of the bottom first. But it's because it's what's important right now. So when I multiply the bottom, remember it's outside times outside and inside times inside. So that's going to give me 2 square roots of 16. Square root of 16 is really 4, so that's now 2 times 4, which is just 8 on the bottom. Golden. Now I can go back and take care of the top. Outside times outside is 4. Inside times inside is 6. And now I just need to make sure that it can't be simplified, and it can't. That's good. 4 square roots of 6. Remember I said make sure that it can't be simplified? Yeah, this can now. It can because my outside times outside can simplify. So back over here, if we were doing division, you could have rewritten this as 4 over 2 times the square root of 3 over 8. Outside over outside and inside over inside, just like multiplication. So over here, this is outside and outside, and they can reduce. 4 and 8 reduce down. So that would give me 1 over 2 times the square root of 6. And it doesn't matter if the square root of 6 is on top or in the middle. It's the same either way. But most people are going to write it on top. Back to it being prettier on top. Not everybody, but most people are going to write it on top. Now, I hope you're wondering why I didn't go ahead and reduce it up here. I could have. I could have made this a 4, instead of the 4 over 2, a 2 square roots of 3 over the square root of 8, but I'd still have that radical on the bottom, and that's what I was really trying to deal with. So I still would have had to have multiplied by the square root of 2 on top and on bottom, and I would have still gotten 2 square roots of 6 on top, and I would have still gotten 4 on the bottom, because that's 16 and the square root of 16 is 4, and I still would have had to have reduced down to a 1/2 square roots of 6. Still going to happen the same way. So it's okay if you want to reduce in the beginning if you can and if you see it, but you have to make sure it's reduced by the end regardless. One more. Okay, not one more. Quite a few more actually. Example 4. Square root of 12 over b. And example 5 is square root of 27x to the 5th over, make sure it goes down enough, 3x. Do these in different colors so that you can tell where they're at. So remember, we're trying to make sure we get rid of the bottom radical. So this doesn't reduce down, so I might as well go ahead and split it up. Square root of 12 over the square root of b. Square root of 12 will reduce, but I'm more concerned about the bottom, getting rid of it. So I have to multiply it by something that's going to make it a perfect root. Now when I start multiplying, it's not going to be helpful for me to go through the numbers 1, 4, 9, 16, because that's not a number. I have to make this a perfect square. So what times b is going to give me a perfect square? And that's going to be the square root of b, on top and on bottom. Because b times b gives me b squared. And 2 on the inside make 1 on the outside. So I end up with the square root of 2 times 2 times 3 times b on top, and the square root of b times b on the bottom. I'm going to show my work on the bottom. I don't normally do that, but I'm going to, so I'm showing it on top. Up here, 2 on the inside, make 1 on the outside. Down here, 2 on the inside, make 1 on the outside. So that leaves me 2 square roots of 3b over just a b. The 2 and the b don't reduce, so we're all good. Over here, before I start taking the square root, before I start worrying about it, if it can reduce, it's good to go ahead and do that. So when I say 3 goes into 27, it goes into 27 9 times, and then x subtracted from x to the 5th gives me x to the 4th. And now I no longer have a fraction. So that took care of that, because this reduced down and that reduced down. So now I just have to take the square root of 9x to the 4th. The square root of 9 is 3. X to the 4th divided by 2 gives me x squared. Wasn't that difficult? Not nearly as difficult as you thought it was going to be, and as difficult as I thought it was going to be. Example 6. Square root of CD over the square root of C to the 3rd D to the 3rd. And then example 7. Square root of x plus 2 square roots of y over 5 square roots of x. Pause it. Let's see how you do. Once again, I'm going to go ahead and make them all 1 square root, which gives me CD over C to the 3rd D to the 3rd. My C's cancel out, leaving me with 2 on the bottom. So that's C squared on the bottom. My D's cancel out, leaving me with 2 on the bottom. And on top I have a 1. Well, that's the same thing as the square root of 1 over the square root of C squared D squared. Square root of 1 is 1, because 1 times 1 is 1. The square root of C squared is just C, and the square root of D squared is just D. It's okay to have things left on the bottom, we just can't have that radical left on the bottom. And then for this one, what do we need to multiply it by? I hope you said the square root of x, because that's what's going to make this a perfect square. We're not worried about that, we're just worried about the radical on the bottom. So for the radical on the bottom, that's 5 square roots of x squared, which gives me 5x, because once you take it out of the square root, it's just a 1. But for the top, the square root of x times the square root of x is the square root of x squared. And then 2 square roots of y times the square root of x is 2 square roots of xy. Square root of x squared is just x. 2 square roots of xy can't be reduced. So you end up with this. And that's how I want you to leave it. Your book may write it a different way, but that's how I want you to leave it. Now, I know you're thinking there couldn't possibly be more, but you would be wrong, because there is a whole nother issue we're going to have to talk about. Everything we have done so far has only had one term in the denominator. It might have had a radical with a number, but that's still just one term. We have to talk about what happens when you have more than one term in the denominator. So that means we're going to have to talk about something called conjugates. If I have the square root of 2 plus x, then my conjugate looks exactly the same, except the sign is different. So my conjugate is going to be the square root of 2 minus x. Likewise, if I had been given this and I needed the conjugate for it, it would be this. Because it's the exact same thing, it's just got a different sign in between it. Let's say I had 2 square roots of 5 minus 3 square roots of 8. You can't combine them, but you can find the conjugate. Remember, it is exactly the same thing, just with a different sign. 2 square roots of 5 plus 3 square roots of 8. What if I had something like x minus the square root of y? Well, then its conjugate is going to be exactly the same thing, but instead of a minus, it's a plus the square root of y. You need to know about conjugates because that's what you have to use whenever you have a denominator that has more than one term. So whenever you have a denominator that has more than one term, then you have to multiply the top and the bottom by the conjugate of the denominator. So let's look at a couple. I don't even know what example I'm on now, so we're going to call this one A. Negative 6 over 5 plus the square root of 7. And then down here we can have B, square root of 6 plus 3 over the square root of 6 minus 4. For the top one, Since we have more than one term in the bottom, and I know that because there's a plus there, that's our second term, that means I need to multiply the top and the bottom by the conjugate of whatever's on the bottom. So that means I'm going to multiply by 5 minus the square root of 7 on bottom, and by 5 minus the square root of 7 on top. So when I'm doing it on top, make sure you use your distributive property. Negative 6 times 5 is negative 30. Then negative 6 times negative 1, because that's what's on the outside, is a positive 6. And then there's nothing on the inside times that square root of 7. So that's my new top. Then we have to talk about the bottom. So 5 times 5 is 25. 5 times negative square roots of 7 is negative 5 square roots of 7. Square root of 7 times 5 is plus 5 square roots of 7. And then 7 times 7 is negative square root of 49. We did a problem like this last section. I talked about one. So you could see how everything just kind of went away and gave you just one number on the bottom. So here, that's why you're doing it by the conjugate, so you can have this happen on the bottom. Our positive 5 square roots of 7 and our negative 5 square roots of 7 cancel each other out. We know that the square root of 49 is really 7, so that gives me 25 minus 7 on the bottom, and 25 minus 7 is 18. So I get negative 30 plus 6 square roots of 7 over 18. Now, you can't leave it like that. Before, when we were talking, I erased it already. I said that I would want you to leave it like that, and it had an x on the top and an x on the bottom. But there was no x on the outside there. There are 3 places it has to reduce for a fraction to reduce like this. It has to be able to reduce here, on the outside here, and down here. If all 3 of those have something in common, then you need to reduce. And all 3 of these do. 6 goes into all 3 of them. So 6 goes into negative 30, negative 5 times. 6 goes into 6 1 time. And 6 goes into 18 3 times. It's got to go into all 3 places in order for us to reduce it like that. Now, once again, your book may not write it that way, but that's the way I write it. If you end up having a question about what the book says later, be sure to text me about it. For this one, we have to multiply by the conjugate, but it's not just any conjugate. Make sure it's always the conjugate of the bottom, because the whole point of doing that is to get rid of our radicals on the bottom. So the conjugate of the bottom is going to be exactly the same, just a different sign. Up here, square root of 6 times the square root of 6, because remember you still got to distribute, gives you the square root of 36, and then that's plus 4 square roots of 6, plus 3 square roots of 6, plus 12, over, down here, you get the square root of 36, plus 4 square roots of 6, minus 4 square roots of 6, minus 16. Now I can start reducing some stuff on top. Over here, I'm going to have a 6. Here, I'm going to have 7 square roots of 6. And 6 plus 12 gives me 18, plus 7 square roots of 6, over. Here, I'm going to have a 6. Those are going to cancel out, and 6 and a negative 16 give me a negative 10. I can reduce those two, But I don't want you to worry about reducing it unless it's all 3 spots. And this one isn't all 3 spots. So since 2 doesn't go into 7, we can't reduce that. And I'm okay with you boxing it just like this. If you wanted to put the negative out front, you could. If you wanted to bring the negative up, you could. But you need to make sure that you distribute it throughout the whole top if you're going to do that. And who wants to go to all that trouble anyway? Just leave it where it's at. It's all good. Okay. So, we need to talk classwork and homework. We went over a lot today, and that's a lot of stuff for you to remember, but it's got to be done. And on top of it having to be done, it's got to be good. In other words, you got to make sure you're not going to make mistakes on it later. So you need lots of practice, unfortunately. So this is page 518. Classwork. Numbers. 1, 5, 11, 15, 21, 25, 31, 35, 41. Nine problems you'll live. Homework. Numbers. 7, 9, 17, 23, 29, 37, and 39. Not 9 problems, just saying. But good ones. So I know you'll be ready. After this section is when you should be taking your quiz, which means you're going to have to know how to simplify radicals, how to add and subtract radicals, how to multiply radicals, how to divide radicals, and how to simplify them once they've been divided. All about conjugates, all that stuff is in that quiz. So you need to make sure you study that before you try to take that quiz. Taking your quizzes cold has been really hurting you lately, so I need for you to study before you take the quiz. If you are curious, oh, I thought they'd have one, but they don't. It wasn't the other section, and I don't want to confuse you anyway, so I'm done with that. I will see you. I won't see you. You'll see me. You'll see me after you're done with the quiz. Not the same day, on a different day. I give you a day off that day. But after the quiz, we'll come back and we'll take care of the last 3 sections in this chapter. And then you get to take your test. Yay! Another chapter gone. Have a good day. Go to your work.